Hi math students, this video is to help you with your Unit 5 focus notes. So you've already done a few of these before, so you're going to watch this video and just fill in this paper as we go. So you can print this and then fill it in as you watch the video, or if you don't have a printer, you can just use your own paper to write down the items that we write down. Either way, at the end, you're going to take a picture and submit it for points. Okay, so for this one, the essential question is, what can you learn about a set of data from looking at a box and whisker plot? So we're not actually going to answer this question here, but we're just going to be thinking about that question as we go. The initial question, so making it a little bit more specific, how do you make a box and whisker plot? Again, we're not going to answer this yet. We're just thinking about how do we do it? And what kind of sources could we use? So we want to use our lesson. So let's go here. So for this one, it's lesson 22.3. So I'm going to write 22.3 on my sources here. Workbook 22.3. That's one place that I can look. So let's see what they have to say about box and whisker plots. And they also call them box plots in this lesson. So either way, box plot or box and whisker plot. So you're going to find some of the vocab that we're going to go over right now. So the first vocab word here on our focus notes is box and whisker plot. And so what I actually want you to do for this vocab is actually we're going to draw a picture. So we'll go into more details on this in a minute, but right now I just want you to draw this picture, something like this for your box and whisker plot. And I will explain all the different parts here in a second, but for our definition, I just want you to draw this picture so you remember what it looks like. We got this box in the middle and some whiskers coming out. That's why it's called box and whisker plot. Okay, remember, if I'm going too fast, you can pause the video at any time and write down these definitions and other things. Median. So we need to figure out what median is. So here in the lesson, they have median, the value that divides an ordered set of data into two groups, each having the same number of pieces of data. So that's a really fancy way of saying the middle number. So I'm going to write middle number. So the median of a set of data is the middle number. So let's use this set right here, 10, 11, 12, 13, 14. So the median of these numbers, the middle number, if I just count in with my fingers, the middle number here is 12. Sometimes it can be a little trickier. Let's do this set of numbers, 10, 11, 12, 13, 14, 15. We'll throw 15 on the end there. If I want to find the median of these numbers, if I start counting in with my fingers, I run in right between 12 and 13. So what I do is I just drop down a little box right here. My median is going to be between 12 and 13. So that would be 12.5 or 12 and a half. So sometimes the median is not actually one of the numbers in the group. Okay, the upper quartile. So the upper quartile, if we go back to our lesson here, I think they call them the first quartile and the third quartile. Yep, right here. So sometimes they call it the upper quartile or the lower quartile or the first quartile or the third quartile. Whatever way you want to write it is fine. But what it means is the first quartile is the middle of the middle number of the lower half of the data. The third quartile is the middle number of the upper half of the data. So that's where the upper quartile or lower quartile comes from. So let's fill that in here on our notes. So the upper quartile, we could also write, sometimes it's called the, third quartile. So either the upper quartile or the third quartile. It's the middle number for the upper set. So let's give an example here. Let's use this 10, 11, 12, 13, 14, 15 example again. So in order to find the third quartile or the upper quartile, you first have to find the median. So we did that up here, but let's just do it again real quick. I'm going to count in with my fingers, and I'm going to find that my median is right in between 12 and 13, so 12 and a half. Now, to find the third quartile or that upper quartile, I'm only going to look at the upper half of the numbers. Okay, so I'm only looking at 13, 14, and 15 now. And I'm going to find the median of those ones. So just looking at the upper half of numbers, the median here would be 14. So this is my third quartile or my upper quartile. It's the median of the upper numbers. The lower quartile, which they said sometimes is called the first quartile, that's going to be the median of the lower half of numbers. So if I use the same example again, I knew my median was 12.5. So now to find that first quartile, I'm going to do the median of the lower numbers. So the median of the lower numbers would be 11. Okay, so these are all the important things that you have to know how to find in order to make a box and whisker plot. Okay, so applying what you know, here's an example of numbers. And notice how they're already in order from least to greatest. If they're not in order from least to greatest, you need to put them in order from least to greatest first. Okay, so what they asked us to do is find the median of the data. So I'm going to use my fingers and I'm going to count in until I get to the middle number. So I got that the middle number here is 9. So that is my median. It's 9. Find the upper quartile. So upper means the bigger numbers, this third quartile. So I'm not going to include 9. I'm just looking at these upper numbers here. Okay, so I'm going to be counting in, and I get 16 is the median of the upper set of numbers. For the lower quartile, I'm going to do the same thing for these lower numbers here. I'm going to count in until I find the middle, and I get 5 as my lower quartile. And that's all they asked you to do here, was to find the median, the upper quartile, and the lower quartile. Okay, another example, we're going to do the same thing. So first I'm going to find the median. I just need to count in here. So this time I'm right in between 36 and 37. So that's where I'm going to kind of drop down this line here and say that's 36 and a half or 36.5. The upper quartile, so the median of the upper numbers, I'm going to count in and I get 38. And the lower quartile, I'm going to count in and I get 30. Okay, so now we're going to take those one step further. We're using the same exact problems here that we just did, but now they want you to actually create a box and whisker plot. Okay, so these are all the things you need to know to create the box and whisker plot. Now we're going to actually create it. So we need a number line. And whenever you draw a number line, you just need to draw the numbers that you need for this problem. So my smallest number is 3 and my biggest one is 25. So I at least need the numbers 3 through 25 on here. I don't have to count by ones. I could count by 2s or 5s or 10s or whatever, but I need to fit these numbers on there and it needs to make sense. So for this one, I think maybe I'll count by 2s. So I'm going to start with 2. And you don't have to count by the same thing as me. I was just trying to figure out what could I count by that fits all those numbers on there, but also kind of stretches it out. So I can tell I'm already going to need a little bit more space. Okay, so that should fit the numbers 3 through 25 on there. So to create this box and whisker plot, you're going to plot 5 numbers. And in your lesson, it tells you that you, where did it say that? The 5 number summary. So you should have read this. You need 5 numbers to plot on your box and whisker plot. And 3 of them we just found right here, the median, the upper quartile, and the lower quartile. But the other 2 numbers are just the smallest and biggest numbers. So I'm going to plot the number 3 on my number line. And I like to draw my box and whisker plots actually above the number line. That way they don't get mixed in with all these numbers. So the smallest number is 3. The lower quartile was 5. We found that up here. The median was 9. And the upper quartile was 16. And then the biggest number is the fifth thing, 25. Okay, so I have my 5-number summary here. Now I'm going to draw a box around these inside 3 dots, like this. I'm going to make whiskers to connect those outside 2 dots, and then I put a line through my median. So that's how you make your box and whisker plot. You have a 5-number summary, you have this box, line through your median, you got some whiskers. Okay, same thing over here. So this is the same problem we did up here. We found the median, upper quartile, and lower quartile. Now we're going to actually make the box and whisker plot. So I need a number line. This time I need the numbers 25 through 41. So you can decide what you want to count by. I think I'll go with 2s again. I'll probably start with 24. Remember, you can pause the video anytime to catch up. Okay, so I'm going to do my 5-number summary. My smallest number is 25. My lower quartile was 30. My median was 36.5. My upper quartile was 38. And then my biggest number was 41. So there's my 5-number summary. I'm going to draw a box around those inside 3 numbers, make whiskers to connect the biggest and smallest number, and a slash through that median. Okay, so next, write a few observations about the data set in the problem directly above this question. So a few observations about the data set. So if you just look at the numbers, you can make some observations, and then based on the graph, we can make some observations. So one thing I noticed is that this whisker is a lot smaller than this whisker. So what this means is that the first quarter of the numbers were all really close to each other. So if we think about separating these into quarters, here's the median. Here was that lower quartile and the upper quartile. So if you think about this as like 4 groups of numbers, right? We've got this group of numbers, 3, 5, and 5. Then we have 6, 7, and 9, 10, 13, and 16, and then 18, 16, 18, 25. So if we think about these sets of numbers, the first quarter of the numbers were all really close to each other, 3, 5, and 5. Whereas the last quarter of numbers was not very close to each other. It went from 16 all the way to 25. There was a range of 9 there. Whereas here, there was only a range of 2. So that's why this whisker is a lot smaller than this whisker. It just means these numbers, the first quarter of the numbers, were really close to each other. So that's something you could write there. So pause for a minute and write something like that down about why the whiskers are different sizes. Over here, our whiskers are generally the same size here. So that means like these first quarter of the data, 25 through 30, was pretty similar to 38 through 41. This one had a range of 5. This one had a range of 3, but they look pretty about the same. One thing I noticed here is that our median is really close to this upper quartile, where it's a lot farther away from that lower quartile. So these are all things that you can write down. And the reason that dot and that line is so far away is because the median here was 36.5, which is pretty darn close to 38. But it's kind of far away from 30. So anyway, these are all observations of what that you could write down. So take a minute, pause, and write one of those down. And the last step here is the reflection. What can you learn from a set of data by looking at a box and whisker plot? So we just talked about a lot of things that you can notice or you could learn just by looking at the box and whisker plot. So even if you didn't have the numbers themselves, you could say things about these box and whisker plots. You can tell how close the numbers are together. You can tell how close the median is to either the lower quartile or the upper quartile. So there's all sorts of things. All these things that you wrote here, you can write as your reflection answer too about what you can learn by looking at a box and whisker plot. So take a minute, pause, and write down something you can learn. Next, how can this knowledge be applied in solving future problems with sets of data? So what I would write here is probably something about how you could use a box and whisker plot to have a visual representation of a set of data. The whole point of a box and whisker plot is to be able to look at this picture and get an idea of what the numbers themselves looked like. Sometimes, especially if you had a list of like, say, 100 numbers, that's really hard to look at 100 numbers. But if you look at the picture, you can get a feel for what the numbers were like. Were they really close together and had a small whisker? Did they have a big whisker because they had a big outlier? Anyway, so something like that here on your reflection. So remember to take a picture of this and submit it for credit.